I'm gonna teach you how to build a 2D game using Jetpack Compose. So there will be a ninja character who's gonna move around and throw weapons. The ninja itself will fight against bubble targets that are spawning each second and falling from the top. This game will have targets with 3 difficulty levels. The first, easy target, is gonna be destroyed with only 1 weapon. The second target, a medium target, that is gonna be destroyed with 2 weapons. And the third target, which is the strongest one, will require 3 weapons to be destroyed. Each one of those 3 targets will have a different color as well as a falling speed. The strongest targets will move slowly, while the easier ones will move faster. The game itself will keep the track of the user's score and the difficulty level. Each difficulty level will increase the following properties: the target speed, the weapon speed, and the ninja speed. The game is considered to be over if one of the bubbles fall below the ninja character. Now, even though I have made this game to be as simple as possible, there is a huge room for improvement. So I hope that this game project wakes up your imagination and you create your own game out of that. But keep in mind that Jetpack Compose is actually not built for games. It's not optimized to handle heavy animations, which is why I recommend sticking with simpler games only. On the other hand, I had a great time building this whole project and it was an exciting journey, which is why I would love to see some improvements in that direction. Anyhow, enough talking and let's get started. I have already generated a Compose multi-platform project that targets both Android and iOS. As for dependency, we're gonna need only one, and that is a sprite view KMP that I have recently published. It will help us to animate the ninja character when moving on the left and right, as well as when throwing a weapon. So before we continue, I will quickly add the resources that we need for this game, like the background image that should be placed on the background. Then we have a kunai weapon and 2 sprite sheets. The first one is used for running and it has 9 frames in total. The second one has just 1 frame instead. Now I'm gonna start this project with a domain layer first. I have already told you that there will be 3 different targets. So let's define an interface with common properties for each one of those 3. Each target should be spawned at a random X position on the canvas. Then the target will move from the top to the bottom using the Y position. The type of this Y property should be an animatable instead. And the reason behind this decision is so that the falling target can animate smoothly rather than seeing an animation glitch. Next, we have a radius of the target. This value can be dynamically changed to increase the size of the stronger target when it gets hit by a weapon and still continues to fall. We have a falling speed property that we can also change dynamically and increase or decrease the speed of the target on the Y-axis. Finally, there is a color of the target as well. Perfect. First, we can create an easy target that implements this same interface. Here, just specify some default values that should be used initially. The color of this easy target will be white. The second target should have pretty much the same initial values except the color. This time I will add a purple color for the medium target. Now, medium and a strong target will also contain 1 extra property called lives. So this is a simple integer value that represents how many weapons can hit this target before it gets destroyed. The medium target will have 2 lives, and the strong target on the other hand will have 3 lives. But you can of course modify those values at your convenience. Great. Next, we need to create a model class that represents a weapon. Unlike target, this game should have only 1 type of a weapon, which is why we don't need any interface with common properties. We can just add a simple data class. Here we need the X and Y properties to properly move the weapon around the canvas. Then the size of the weapon and the shooting speed as well. After that, we can add a simple enum class to represent the game status. So we're going to use this game status to decide when to stop animating, when to display the game over screen, and other useful operations in this project. Then we can add another enum class. This one should be used to indicate the movement direction of the ninja character, so that we can know when exactly to stop animating the running sprite sheet and more. For now, I will add one more, or actually two more data classes. So this game data class will keep track of the game status, score, and the game settings. Game settings will hold some common properties that we're gonna later use to modify and increase the game difficulty. We're gonna introduce difficulty levels later in this video. Great. Alright, so we are gonna start implementing this game one step at a time. The first step is to add a static background that we have already in our resources. We can create the new Kotlin file and name it main screen. So this whole logic and the UI of this game should be placed inside this single file. It will be easier for me for the demonstration purpose. On the center of this screen, we will add that single static image. The parent layout should be a box, because we're gonna stack multiple layers on top of each other. The background image will be on the bottom of this box, behind all other layers. The image itself will take the full screen size. Also, in the main activity, don't forget to call enable edge to edge so that we can expand this game on the entire screen. Awesome! Next, before I add this ninja character, we need to create the logic to handle finger gestures when we hold our finger on the screen and move on the left and right. That way, we will properly animate the movement of the ninja character. I will create an extension function on await pointer event scope. So this scope suspends and install a pointer input that can await input events and respond to them immediately. This function will have 3 lambdas so that we can properly react and animate the ninja character while observing finger gestures. We're using a while block to make sure to observe those gestures only if the game is in the started state. Here we have a await pointer event, which waits for the next pointer event, like the user touching the screen. This initial down variable looks for the first touch event where the user has pressed the finger on the screen. If no such event is found, then it skips to the next iteration of the loop. The primary pointer ID is used to track the specific finger or a pointer on the screen. So if the user touches the screen with multiple fingers, each finger will get a unique ID. However, in our case, we're gonna be interested in only one finger gesture. Next, we have a previous position property, which is initialized to the previous position where the finger first touched the screen. We will use this value to calculate whether the user has moved on the left or on the right. Then, this function enters another loop, waiting for more pointer events. Change variable is the information about the pointer that matches the primary pointer ID. In this case, we are observing only a single finger. If the finger is lifted, so if the user stops touching the screen, then this condition will be triggered. OnFingerLifted lambda will be called to notify that the finger has been lifted. And of course, the break statement will stop this loop, meaning the gesture is finished. Then after that, we have a current position variable that stores the current position of the finger. We have a delta x variable that calculates how much the finger has moved horizontally along the x-axis. The previous position is important to calculate whether we have moved on the left or on the right. So after processing this movement, the previous position is updated to the current position of the finger so that the next movement can be measured correctly. And finally, we are consuming this gesture. So this ensures that the event is consumed, which means that the system doesn't propagate this event furthermore. It makes sure that our function handles it exclusively. Bottom line, the second loop will continue to track this finger's movement until the user lifts their finger off the screen, at which point this gesture is considered completed and the loop exits. Now, we can go back to our screen, Then specify that pointer event modifier on our box composable. Then call await pointer event scope, and then within this scope we can call our new function. Great. Also, don't forget to create and remember game object so that we can pass that current game status here as well. So next we need to add that ninja character on the screen so that we can utilize this finger gesture and start the running animation in either left or right direction. For this to work, we need to use a sprite view campy library that I have mentioned. If you want to learn how this library actually works, then be sure to check my previous video where I have explained that in more details. Anyhow, on top of this composable, declare move direction property so that we can keep track of that. A default value should be none. Only after we trigger on left or on right lambda, then we can update this movement. Plus, don't forget to reset its value when the finger is lifted as well. Great. Next, below this background image, we can add a canvas where we can draw the ninja sprite sheet animation as well as the targets and the weapons. To draw the ninja, we can call draw sprite sheet function. Here we need to pass multiple parameters. For now, I will just pass here this sprite flip parameter and make this sprite sheet look towards the left side when we move on the left, or the right side otherwise. So just pass here the null because that's a default value anyways. Now let's scroll all the way up and we can create multiple variables. So first we need to remember two sprite sheet states for each one of those two sprite sheets that we're gonna use in this video. The first one is used to animate the running ninja. If you recall, it has 9 frames in total and 3 frames per row. This second one will have only 1 frame on the other hand, because this one will not actually animate. It will represent a static image when we are not moving. After that, we need to observe the currently animated frame of those two sprite sheets, because we need to pass those parameters inside the draw sprite sheet function down below. We also need to observe is running property of the first running frame so that we can know when this animation is running and when it stops. Finally, we need to create 2 more variables to represent a sprite spec for each one of those 2 sprite sheets. So this is the place where we can pass the actual sprite sheet files. And then the size of each frame from those sprite sheets. For the width and height of the ninja frame in this sprite sheet, I will create 2 constants on the top. So each frame inside the sprite sheet should have the same size in width and height. That way, this animation will look smooth. And if you are creating your own sprite sheet, be sure to get and remember that size. Great. We also need the screen width value. So to calculate that value, we can use on globally position modifier on the box composable. I will create here 2 more variables for both width and height, because we're gonna need both of them later. And of course, don't forget to set their values in the globally positioned modifier. We need 2 more variables that we can use to extract the image from those sprite specs, since that's a required parameter of the draw sprite sheet function. So now let's go down below to pass all these parameters. We can use that is running property that indicates which parameter to use here, because we will use both of those sprite sheet files in this single draw sprite view function. So when this is running property of the running ninja animation is equal to true, we want to use the running ninja sprite sheet. Otherwise, when we are not moving, we want to use that standing ninja frame instead. So the offset parameter is used to properly calculate the movement of the ninja when we use the finger gestures. So let's create here the ninja offset x variable on the top and set its default position to be on the bottom center of the screen. To calculate the screen, we can use the screen width value divided by 2 and add the ninja frame width. We are wrapping it inside the animatable because that way this whole animation will be a lot smoother. So let's go down below and pass this variable as an x property of the int offset. As a Y property, we need to place this ninja on the bottom of the screen. And of course, we can use that screen height property to do that calculation. Awesome. Before we continue, let's launch this application to see whether this ninja will be spawned on the bottom center of the screen. And as you can see, it looks pretty good. Okay, so the reason why our ninja character is not centered on the screen is because that we need to add here the key to be the screen width. So whenever our screen width changes, we need to apply here and calculate this animatable. So let's add here the key 1 to be screen width. So the screen width will initially have a value of 0, which is why we need to calculate this value as soon as we calculate the actual screen width. And also here we need to say minus ninja width divided by 2, okay? So now our ninja character should be centered. There we go. It looks perfect. Next, we need to animate the ninja sprite sheet whenever we trigger that on left and the on right lambdas. So let's do that. Since ninja offset x is an animatable type, we need to create and remember one coroutine scope if we want to animate that movement of the ninja character. So when we move either on the left or on the right, we want to start that running sprite sheet animation, and when the finger is lifted, we want to stop that animation. So when the animation is stopped, then the standing ninja sprite sheet will be used instead, because that's the logic that we have added in this draw sprite sheet function. Perfect. Next, I will launch the coroutine scope on the main dispatcher and add the while loop. So only if the ninja is running, then we want to update and animate its offset x property. The speed of this offset x property can be around 30 milliseconds, for example, but you can change that value on your own. For the target value, we want to use that ninja speed float value from the game settings to specify for how much we want to move our ninja character. By default, I have set this value to be 15, but you can change that. However, now a new problem arises. So we need to make sure not to move the ninja outside of the screen when we are moving either on the left or on the right. That means that we don't want to allow using a negative value for the x offset more than we should. And for the right side, we can use the screen width to do the calculation and make sure that our ninja will not wander around the screen when we move it. Alright, so now I think that we can test this out and see whether this ninja will move properly. Okay, so let me quickly add the launched effect block that we're gonna trigger only once we run the application. That's when we want to set the game status to started, or otherwise we wouldn't be able to move. Plus, be sure to wrap this game instance within the mutable state, so that we can observe and get notified when the game status changes. Great. So now launch the application and try moving left and right by tapping and moving your finger on either one of those sides. You'll notice that the ninja is properly moving on both sides, and if we reach the end or the start of the screen, our character will not move outside of the screen, which is great. Also, you can notice that this sprite sheet flips correctly depending on which side we move to. Awesome, we're doing great. The next step is to implement a feature to start throwing weapons at the same interval when the ninja is moving either left or on the right side. When the ninja stops, however, we also want to stop throwing weapons. To keep track of the weapons that we are throwing, we can create a mutable list variable which will be initially empty. Then I will add one launched effect block that will be triggered when the ninja is running and when the game status is changed. Then we can add the while loop and keep spawning new weapons every 150 milliseconds, for example. I'm quickly gonna add here the constant for the weapon spawn rate as well. Then, after that delay, we can add the new weapon in the list. So the weapon's start position should be somewhere on the center of the ninja frame, a little above the frame. We can add one more constant for the weapon size. In this case, we can set the weapon radius to be 32, because that's the width of this weapon image that I have added to the resource directory. Now for the shooting speed, I have added here the minus in front of the weapon speed because we want to move this weapon negatively on the y-axis. The positive value on the other hand would move to the bottom instead. So with this, we're just gonna spawn the weapon on the bottom of the screen above the ninja character, but we're not gonna move that weapon towards the top. For that, we do need another launched effect block to handle that movement. But before that, we also need to draw this weapon within the canvas. So let's add here one for each loop so that we can draw a weapon image for each weapon in this list. By the way, for this weapon, we don't need to use the draw sprite view function, we can simply use the draw image instead. And for that matter, just be sure to create one variable on the top to get that image from the drawable, and we're good to go. While we are here, I'm gonna also add another launched effect block to spawn targets along the weapons. Unlike weapons that will spawn as long as our ninja is running, targets will spawn at a fixed interval until the game is over. So let's add another constant to represent the target spawn rate. In this case, I will set the target to be spawned every 1.5 seconds. Unlike the first launched effect block, here as a key I will just add the game status. And while the game is in a started state, bubble targets will keep spawning every 1.5 seconds. Before we continue, create another mutable list to keep track of the targets. By default, that list should be empty. Then go back down below and create the random x variable that will be used to randomly generate the spawning position of the targets on the x-axis. So from 0 to the maximum screen width. Because we don't want to spawn targets outside of the screen. That will be bad. Down below, create another variable to calculate whether that random value is an even number. So the reason why we need this value is so that we can spawn a different type of targets on different positions. That way we can randomize the game a little bit. Now, since the target will be a simple circle that we'll draw on the canvas, let's also add here one more constant to represent its initial size. And for now, I will set the size of the target to be 40. The size of the medium and the strong target will slightly increase when hit by a weapon and before getting destroyed. So if the x position value is an even number, we want to spawn the medium target. Its initial y position should be 0 because we're gonna spawn it on the top of the screen. The falling speed can be grabbed from the game settings. Then, in the else-if case, I will add another calculation to specify when to spawn strong targets. So in this case, I want to spawn them only on the right side of the screen. This means the strong targets will spawn in the rightmost 25% of the screen. Plus, the falling speed of the strong target will be slightly slower than the other two. And in the last case, we can specify and spawn an easy target. Great! Also, don't forget to add the for each loop inside the canvas to draw a circle for each target that we add in this list. As you recall, we will have 3 different targets with 3 different colors. Plus, they will randomly spawn on the top of the screen. So, before we launch this application to see our progress, let me quickly remove that small launched effect block that we have used to update the game status. Because now we will add a black overlay on top of our screen to allow users to manually start the game. So down below, after the box composable, I will add an if check to display this UI only if the game status is equal to idle. When that happens, I want to show here a black overlay with a text and a button. When the button is pressed, we want to update this game status to started. Then, below that, I will add another overlay and another if check to see if the game is over. In that case, we want to display here a game over text as well as another text to display the game score. Plus, when this play again button is clicked, we want to update this game status but also reset the score. While we are here, I will add another UI element to display the current game score. This UI element will be visible all the times, however. On the top. Great. So now if you launch this application and press that play button to start the game, you will notice that targets will keep spawning on the top. Plus, when we move the ninja character, weapons will spawn on the bottom. However, neither one of them will actually move. So we need to create the logic and make them move towards each other until one of the targets reaches the bottom, in which case the game should be over. For that matter, I will create another launched effect block. So this block will be triggered when the game status changes. And I will add the while loop to keep this code executing while this game is running. Inside, I will call one function called withFramesMillis. So the purpose of this function is to synchronize the game's logic updates, like movement and collision detection, with a display's refresh rate. It will ensure that the game runs smoothly and efficiently by tying updates to the rendering frames. This will prevent stuttering and choppy animations caused by unsynchronized updates. Without this function, the loop might run as fast as the CPU allows, which could waste resources by performing unnecessary updates. After that, I will loop through the targets and weapons to animate the movement of those two kind of objects. Since the target's Y position is an animatable type, we will use the coroutine scope to trigger that animate2 function. Then, below that, we need to create the logic for a collision detection to detect when a weapon hits the target. First, on the bottom of this Kotlin file, I will create that function. I will simply paste that code. But overall, the purpose of this logic is to return a boolean value when those two objects hit each other based on their X and Y positions. After that, go in the launched effect block, and here I will create two iterators for a target and a weapon lists. So the reason why I'm gonna use a simple iterator on the weapon list and a list iterator on the target list is so that I can actually update the target's properties along the way. So only the list iterator will allow us to set those values. We should dynamically set the values like the number of lives and the size of the target. So those two properties should be dynamically updated. So when the weapon collides with the target and the target has at least one life, then only the weapon should be destroyed. Otherwise, when the number of lives is 0, we want to destroy both the target and the weapon at the same time. Also, when the target gets destroyed, don't forget to update the game score and increase it by 5. Of course, you can modify this score by yourself and, for example, add the lower number when you destroy some easier target and add the higher number when you destroy stronger targets. It's your choice. So far, so good. And the last important thing here that is left to do in this launch effect block is to handle the case when the game is over. We want to check the target list and observe when the Y property of the target becomes greater than the screen height. That would mean that the target has actually passed below the ninja character, in which case we should update the game status to over. When that happens, don't forget to stop the running ninja animation and remove the rest of the weapons and the targets from the screen. Awesome. So even though there are a few minor things that we need to add here in this game as well, let's stop for a moment to launch the application and see whether this collision detection actually works. When the game starts, targets will slowly move to the bottom of the screen, while weapons will move towards the top. When we hit medium or strong targets, you will notice that they will not disappear right away until we hit them with 2 or 3 weapons, because they have more lives. And if we want some of the bubble to fall beneath the ninja, then the game will end immediately. The running animation will stop, targets and weapons will be removed from the screen, and this black overlay should appear. You can also see the game score as well. Great. Since emulators can be slow sometimes, it's better to continue testing this game on a real smartphone device. Now, to enhance the user experience, we're gonna add the pop sound that will be played every time the weapon hits the target. I already have one MP3 file. So now, in the common main resource directory, let's create a files folder and paste that file. Next, we need to create the logic to play that sound on both Android and iOS. So first, we need to add a couple of dependencies that we're gonna need. I will add an extra player dependency for the Android target, then coin core, coin compose, and a coin Android as well. We're gonna need those to properly inject the context for the extra player in Android target. So coin Android and the media 3 extra player artifacts should be specified inside the Android target, while the other two in the common main. Next, let's create here an expect declaration for the audio class with a single function to play the sound. Below that, we can also create and define a one list variable that will hold only one string item. You can of course use this list to add some more sounds if you wish. That item should represent the path of that audio file. Great. Now let's implement the actual declaration for Android and iOS. First, let's handle the Android part. So I'm just gonna paste here the code without too much explanation. It's a simple logic. Plus, this Android class will take the context object that we're gonna need to inject afterwards. For the iOS part, on the other hand, I will also paste here the code that will allow us to play that sound on iOS platform. No need for further explanations. The next step is to set up a dependency injection and inject the context object. So create the new Kotlin file where we can place that function to initialize the coin library. Plus one expect declaration for the coin module. This initialization function should be called when we launch the application on both Android and iOS. And the target module will be implemented separately because the Android part will require the context object while the iOS won't. Let's also implement the actual declaration for the target module. Here, we just need to provide the singleton instance for the audio player class. For the Android target, we need to specify the context and just call the Android context function, which is the function that is part of the coin library, which does contain the Android context. Now we can go and create an application class in our Android main source set. Then we can override the onCreate function, call that initialize coin function, and pass the application context to it. That way, coin library can take that context and pass it to our audio player class. Don't forget to add this application class to the Android manifest file and we're good to go. Now for the iOS target, simply initialize this class without any parameters, because the iOS doesn't know anything about the context object. Finally, initialize the coin library on iOS by opening the main view controller and calling the initialize coin function when the iOS app starts. So finally, after all of this setup, let's initialize this audio player class by using a coin inject function in our composable. And then, when the weapon collides with the target, call that play function and pass a 0 number for the index value of that audio file that we have already declared, which will then immediately play the MP3 file that we have already added. Great. Now the last thing which I want to implement in this video are difficulty levels. So I have already mentioned that we could tweak this game quite easily to make it easier or harder for users to play. For example, by updating 3 properties like ninja speed, weapon speed, and target speed. The focus in this video should be on the target speed. By making targets fall faster, we could increase the game difficulty. Also, you could add some more lives to already existing targets and increase the difficulty level as well. I will open up that game Kotlin file and create the new enum class called game level. A common property should be a score of an integer type. So this will act as a boundary for our levels. For example, the level 1 will count from 0 to 10, and after the user crosses that number, then the second level will apply, and so on. Down below, I will create the list of level settings, where I'm gonna add 5 game settings that we can pair with those game levels. In this demo, a focus will be on the target speed, to make catching those targets a little harder. Then, below that, we need another list to map each level to a specific game settings object. Awesome! Finally, let's go back to our main composable function and add one additional launched effect block to handle the levels. We're gonna filter the levels and get only the game settings object when our current score reaches a specific level threshold. When that happens, we want to apply and update the game settings property of the game object. That way, those properties will apply immediately. Also, we can add one more text to observe the current game level in real time. Plus, don't forget to reset the game settings object when we click that play again button as well. So with this, I think that we have finally completed the game. We can start this game on both Android and iOS. This time I'm gonna launch this application on real smartphone devices, and we can see that everything works as expected. The game looks a lot smoother on a real device. And you can see that we are able to hear those popping sounds, as well as keep track of the current difficulty level. So I hope that you have enjoyed watching this game development video tutorial. I hope that it will bring out the creativity and the imagination in you, so that you can build games on your own. However, as I already mentioned before, you shouldn't use heavy animations with games in Jetpack Compose, because memory management is not built to support this use case. But nonetheless, simpler games are totally okay. Don't forget to leave a like if you appreciate this content, and thank you for watching.